code entry, and it treats some code entries as data entries. So it's using some kind of heuristics, but sometimes it doesn't work very well. And how about the security implication scores working? It's something like, let's see, it's working like just using signatures right now. So it's a signature-based scoring system. So if you find some patterns inside the patches, then it will treat that part as a kind of security-related part or something, and it like accumulate all the scores, and it just compares the scores with other entries, and it just shows which one is more likely to have some security patches. So you might wonder what kind of signatures. So here's simple examples, like how about string length? If there was some buffer flow issues, the only way to fix is to check the length of the original string. So in that case, you will call string length. And how about the string, safe string API? Like Microsoft SDL. How many people know about SDL, Microsoft SDL? How many people heard about that? Yeah, looks like more people know about that now. So it's a kind of program like they are like a development life cycle thing, and it's like originally SDL meant in other like companies it meant like a software development life cycle or something, but in Microsoft they changed it to like a secure development life cycle or something. So it's about like methodology for like developing some secure product. So from that guideline, maybe they need to use some safe string API. So if you find that API, it means that they fixed something in that function. How about the 0x FFF, some patterns like that? It means that they are checking some big numbers. So maybe you can just use this constant to check some integer flow. I will show the real example now after this. So the cool thing is that it's customizable. So the whole engine about the security implication score is written in Python. So it's a kind of example from me. So you can just rewrite the logic yourself, or you can add the signatures to yourself very easily because it's written in Python. And the actual question is, you might wonder, does it really work? So I tested with some Adobe binaries. It's called acro-aldi32.dll, and they recently, like a few months ago, they patched to like a 9.3.3, and I diffed with 9.3.2, and it created like a 3630 functions modified. And I found that the entries with SI's number greater than 0 was only under 692, and the functions with SI's number 1 was only under 70. And actually the entries with SIS number 5, it looks like it's under 20, so it saves you a lot of time. You don't need to look at like other entries with SIS 0. So looks like it's working. So I'm going to show some demo here. So actually, the actual diffing process takes a few minutes, so it's not feasible to run that thing real time here. So I prepared some examples here. So here, this is the main menu. Actually, this is some SKArt. It's a Darun Grim. And there are menus like files import and files list and Microsoft patches list and about this screen too. So if you go to files import here, it just shows some like input box. And if you like put something like C Windows and press the import, it will take like 10 or 20 minutes to import all the files from C Windows directory. And it will like import all the PEP files from there, and it will create the index for them. So you don't need to worry about the version numbers or where to find the files or something like that. You don't need to worry about that. So actually, you can use like you just need to set up some virtual images for every OSs, and you just need to import them from like if the machine is, you just need to like share the directory, and like if the machine is like 0.1.6, and if you share the Windows directory, then you can do this and just share, and you can just import all the files from the remote like virtual machine or something. In this way, you can collect all the binaries for each operating system you want in a very short time. And the actual result will look like this. I only imported some files, few files here. So it shows Microsoft Corporation here. And it will show all the files that it had imported. And if you look into, looks like usually many bugs are found for like a WKS, svc.dll. So there are all the files here. Simple problem. So you can see all the binaries here, and you can select the files to diff. Here it shows the version string and the OS name like XP, SP2, something like that, and you just need to press here start diffing, and it will take, this binary is not that big, and it will take like a few minutes to finish. So here's, what file did I use? Yeah, here's the, after that it will show some function list like this, and actually it's from WKS svc.dll. It's a kind of, it's a RPC service DLL, and it's called workstation service. And I diffed 2 binaries here, and the cool thing is that the unpatched binary doesn't have symbols because it was too old maybe. And the patched binary has the symbols. So actually you can know the exact name for the old binary, even though it doesn't have any symbols. So the first entry has, it actually had this name. So if you click this, then, oh, not this one. If you click this, yeah, looks like it's having some problem. And if you click this, it will, yeah, this is actually, yeah, because it has some problem. This is actually from other function, netp manage IPs connect. You can find that the result here, you can see that the red parts are some blocks that has been inserted to the patched part. So the left side is the original binary, and right side is the patched binary. So the red parts are all the new code that has been introduced to the new binary. So it's fixing some problems. So you can find some interesting things like this one. It's comparing some byte with 5CH, which is, I believe, it's a backslash, I think. And other examples are like this one. The original code was just 1 block, and it's doing, I'm not so sure, it's doing very simple thing, but the patched binary is doing a lot of like, it's calling some net path canonicalize thing, so it's doing more processing, and it's also checking something like this. Like it's comparing the length of the string. It means that there was some problem with some string operation, maybe. So you need to dig into more to get the real idea. And the cool thing is that if you click the Open IDA button here, then it will actually shows the result on IDA. It will be synced through some IPC. So I chose the first entry. This is the result. So if you look into this, it will actually colors the blocks. So actually you can actually analyze the vulnerabilities here yourself and use IDA, and you can just trace, because it shows the color, you know which blocks have the patches maybe, so you just need to trace the variables and registers here and see if it has any kind of security implications. So yeah, this is the demo that I can show now, and let's go ahead. So I'm going to show, because the demo doesn't show anything like a cool thing, right? So I'm going to show some real examples that has something really cool. So the examples here are just showing that the signature system that I invented really works. So if you have the patterns, then it will generate more like greater scores. So I'm going to show, I think, yeah, it will be like 3 examples that has one-day exploits that hasn't never been like released before. So, but don't panic. The old exploits, all the vulnerabilities already have been patched a long time ago. So, I don't think there will be any like wildlife exploits that will exploit this. Mm-hmm. So the first example is stack-based buffer flow. It's MS06-07T. Yeah, looks like the picture doesn't work well here. Yeah, that's cool. So, yeah, this function has, actually I found this vulnerability using some static analysis, and it was very easy because it was found directly from the RPC call. Actually, there is some RPC, and you can find the RPC service code very easily using some tools like MIDA, and you can find this kind of vulnerability very easily, like a few years ago. Looks like the Microsoft patched a lot of RPC issues, so I'm very skeptical you can find these things now. If you can read the disassemblies here, you can see that the argument here is user controllable. Actually, this function nepp manage IPs connect is exposed through the RPC. So user directly control ARG0 argument, and it's going to ESI register, and it's actually used for the function for swprintf. So if you are familiar with any kind of a stack overflow, so swprintf doesn't do any kind of security checks. It doesn't do any kind of length check. So it will overflow EAX, the buffer EAX is pointing to. So the username, it's actually from the username variable, and it's actually from here, username. is here.